Today, let's talk about quantum threats to symmetric cryptography and hashing functions, an important topic as we move toward the era of quantum computing. Most people hear about quantum computers breaking RSA or ECC, which are asymmetric encryption algorithms. But symmetric systems like AES and SHA-2 are also affected, just less severely. Quantum computers don't completely break them, but they reduce their security margin, which means we need to strengthen these systems to stay safe in the post-quantum world. Let's start with Grover's algorithm. This is a quantum search algorithm that can find a target value much faster than a classical computer. For example, if a normal computer needs about 2 to the power of 128 steps to brute force a 128-bit AES key, a quantum computer using Grover's algorithm could do it in only about 2 to the power of 64 steps. That's a square root speed up. So effectively, quantum computing halves the security strength of symmetric keys. That means AES 256 today provides about the same protection in a quantum world as AES 128 does now. Next, let's look at hash functions and the BHT algorithm. Hash functions like SHA-256 are designed so that it's extremely hard to find two different inputs that produce the same output. That's called a collision. Classically, finding a collision in a 256-bit hash takes about 2 to the power of 128 tries. But a quantum computer using the BHT algorithm could do it in only about 2 to the power of 85 tries. That's still a huge number, but noticeably easier than before. This means that even our strongest hash functions may need reinforcement. So, what can we do? First, increase key and hash sizes. If quantum computing halves security strength, doubling key lengths brings it back up. That's why we recommend AES 256 instead of AES 128, and SHA-384 or SHA-512 for hashing. Second, practice strong key management and regular key rotation. Rotating keys regularly reduces risk, even if a key is somehow exposed. Secure key management systems help automate this safely. Third, use hybrid cryptographic systems. These combine traditional encryption methods with new post-quantum algorithms, ensuring security both now and in the future. Many organizations are already testing these hybrid systems to prepare for the quantum transition. In conclusion, while symmetric encryption and hashing are more resistant to quantum attacks than asymmetric systems, they are not completely safe. Quantum algorithms like Grover's and BHT make brute force and collision attacks faster and more practical. But by using larger keys, stronger hashes, and modern key management, we can keep our systems secure. Quantum computing is changing the rules, but with smart adaptation, symmetric cryptography will continue to protect our data in the quantum era.